fifth grade. Today we're going to be doing Module 4, Lesson 8. And today's lesson is going to be continuing multiplying these fractions by a whole number, except the difference with today's lesson is that we are going to be showing a lot of different ways on how to do this. So far, we've learned how to do the arrays and we've learned how to do the tape diagrams. So I'm going to be comparing and contrasting the tape diagram today with the numerical way later on. And then we're also going to be looking at repeated addition. So you're going to be learning a lot of different strategies today. So you might look instead of just doing these on your desk so that you can copy everything down and have these for your exit ticket and possibly your homework and problem set. With that said, let's go ahead and get started with Lesson 8. So for today's lesson, we're going to be looking at the difference and similarities between problems. So for example, this one right here is 2/3 times 6. We have that multiplication symbol. And then this side, we have 2/3 of 6. Now, you might look at these and think that they are different problems, but actually, these are the exact same thing. So this one is showing me that I'm doing 2/3 times 6. This one is also showing me 2/3 times 6, because remember, this x right here, this multiplication symbol, can also be seen as groups of. So normally when we solve these problems, we last learned how to do a tape diagram. So I could still do a tape diagram to solve these. I could show that this entire tape diagram is equal to 6. I could split it into thirds. I know I have to find 2 of these thirds. And I need to figure out what 1 unit is first. So 1 unit is going to be 6 divided by 3, which equals 2. So I know that 1 unit equals 2, but I need to find what 2 units equals. So that would be 2 times 4. And 2 times 4 would get, 2 times 2, got a little ahead of myself. So 2 times 2, and that would give me 4. So all together, 2/3 of 6 will give me an answer of 4. But we're starting to move away from this tape diagram, and now we're going to be finding ways to just do our problems numerically. So what this means is that when I look at this problem, I say 2/3 of 6, 2/3 times 6. But remember, this of means that I have groups of. So I have 2/3 groups of 6. And I could show this as this, but I could also show it in a different way. And I want you to stick with me on this. I could also show it as 2 times 6 over 3. Because remember, in a few lessons past, remember, these problems are all multiplication problems, and when you multiply fractions, you just get to go straight across. So normally, this 6 right here, since it's a whole number, this 6 is in my numerator, and this 3 would just stay in my denominator, because underneath the 6, it's just a 1. So 3 times 1 is 3. So basically what I did to get to this step is I did 2/3 times 6 over 1. I went straight across. I'm just setting up basically what you're seeing here. So I didn't even multiply yet. I'm just kind of skipping writing out this step, and I'm just putting it all together here. And again, this is kind of like the work I'm doing over here. It's just in the number way, the numerical way, so we can start doing that more advanced math and a little bit quicker as well. So we could do it like that. And now what I have right here is 2 groups of 6 over 3. Now, if there's some reason that you're having some difficulty with the multiplication problem that you're seeing, you can actually show this as a repeated addition problem. And what that means is my denominator is still going to be 3, because remember, that doesn't change. But what I can do is I can show this as a addition problem, basically. So if I have 2 groups of 6, that means that I have 2 6s. So if I had 2 groups of 6, that means I have 2 6s technically on the top, because 2 times 6 is kind of like 6 plus 6. So if that helps you, you can do either of these ways But if you're having difficulty with multiplication, this might help you out over here. And again, I got that because I have two groups of 6, so I'm adding 6 2 times. So if I were to solve this one right here, I would do 2 times 6, which gives me 12 over 3. And if I were to solve this problem over here, I would get 6 plus 6, which is 12 over 3. And as you can see, I got the same exact answer on both sides. Now, what I can do with this is I can think of this as a division problem, and I can think of this as 12 divided by 3. And I know that 12 divided by 3 gives me 4. And on both sides, that is true. So both of these ways will give me my final answer of 4, just like our tape diagram did. We're just trying to eliminate so much work so we can try to finish these problems a little bit easier. Now, there's one more way that we can do this. So we have our tape diagram, we have multiplying, we have repeated addition, and then our final way is going to be something that's going to help you later on when you're multiplying and dividing bigger numbers. But what that is let's say I'm just going to rewrite this right here. So I have 2 times 6 over 3. And what you can do is you can see if you have any factors that can easily be divided here. And what I mean by that is I want you to look at the numbers that are on the top and the numbers that are on the bottom. And I want you to think, is there anything both this 6 and this 3 can be divided by? Or is there anything both this 2 and this 3 can be divided by? And you're kind of like simplifying your multiplication problem right here. And you are creating something that is easier to work with. And I'll show later on why this is going to be a very important strategy. So what I can do is I can look at 6 and 3 because I know that I can divide both 6 and 3 by 3. So what I'm going to do is I'm going to cross out both of these numbers and I'm going to think in my head, what is 6 divided by 3? Well, 6 divided by 3 is 2. And then 3 divided by 3 is 1. So I'm going to put a 1 right next to that. So it's basically like I just created a whole new problem. So now what I have is 2 times 2, which gives me 4, over 1. And I would get my final answer of like 4 divided by 1, or just 4. And that also gives me a different type of answer. So if you're doing this in your notebook, which I highly suggest, you can label this as like your tape diagram, just regular multiplication. You have your repeated addition right here. And then over here we have we'll call it the simplify strategy. So you can simplify your problem and then divide. Because if you noticed, what I did is that when I got to this step right here where I would normally have to do 12 divided by 3, I now have 4 divided by 1, which is a much easier problem. So if you have factors, if you're really good with those factors, then you can easily see what new problems you can create out of that. So make sure you're working on those facts. So we are going to explore this a little bit more with our next problem. So I'm going to go ahead and erase this, and we'll see how to use all these different strategies. So we have 3/5 times 10. So 3/5 times 10. And what I'm going to be doing with this problem is I'm going to show all the different ways to solve this problem. So the first way I'll show you is the tape diagram, if that's still a method that you like doing. So over here, I have my tape diagram. I know that my whole tape diagram equals 10. I'm going to split this into fifths. So we split it into fifths because my denominator is 5. And I know that I need to find 3 of these 5 parts. So to figure out what 1 unit equals first, I have to do 10 divided by 5, which equals 2. So I know that 1 unit equals 2. And now I need to figure out what 3 units are going to equal. So I'm going to do 2 times 3, which equals 6. So 3/5 of 10 is 6. So I know my answer, but let's find the ways that we can do this numerically. So first what I'm going to do is I'm going to show how I can write this problem as a multiplication problem, having everything together. So to do that, I know that 3/5 times 10. Remember, this 10 technically has a denominator of 1. So if I were to rewrite this, I can think of this as 3 times 10 on the top. So 3 times 10 on the top over my denominator of 5. That 5 is technically being multiplied by the 1 that's technically underneath that, but we don't see it because we don't really need it there, because I know that 10 divided by 1 is still just 10, so it doesn't really change the problem. So what I have right here is I have 3 times 10 over 5. And what I'm going to do with this now is I'm going to solve from here using what I have. So I have 3 times 10, which I know is 30. So I have 30 right here over 5. So that 5 doesn't change. And now if you're really good with those facts, you can easily divide this. So I have 30 divided by 5, which gives me 6. And remember, you can think of those fractions as division problems. It's an easy way to do it. If you really need to, if you need to set up a standard algorithm, do it like that, you can, or you could think of it as like 5 times what is 30. So you have a couple of different ways to do that, but practice those facts so you can easily get your answers. Now, I could also show this as a repeated addition problem if I needed to. So how I would do that is I would show 3 groups of 10. So that means that I have 3 sets of 10 basically. So I have 10 plus 10 plus 10 over 5. So I have 3 sets of 10 because my first number is 3, because it's telling me I have 3 groups of, so 3 groups right here of the number 10, and then that's why I have the number 10 there. So now I just have to add up 10 plus 10 plus 10, which gives me 30 over 5, and then again I would have to do 30 divided by 5 and get 6. This repeated addition way is a little bit easier if you are multiplying numbers that you don't know how to multiply, or maybe they're really big and you're not sure how to do it. So that might be a reason why you use this repeated addition strategy. Now, for the very last one, this is that simplify strategy we were talking about. So again, I'm going to rewrite the same exact problem right here. So I have 3 times 10 over 5. And what I'm going to do with this one is I'm going to look at my numbers and I'm going to think about, is there anything that at least 2 of these numbers can all be divided by? So 3 and 5, I can't think of anything, but 10 and 5, I know that both 10 and 5 can be divided by 5. And if you have to use those greatest common factor skills that we learned about a little while ago, so that can help you out to find what are the factors you can divide both 10 and 5 by. So again, what I'm going to do is I'm going to cross out the 5, I'm going to cross out the 10, and I'm going to mentally do 10 divided by 5, which is 2, and then 5 divided by 5, which is 1. I'll just write those new numbers right next to the numbers that I just crossed out. Now I can rewrite my new problem, or solve it from here. So I have 3 times 2 now, which gives me 6. And then I have a 1 on the bottom, but I know that 6 over 1 just equals 6. And again, this strategy is really useful if you know your facts and you want to simplify a problem down so that your work in this section is not as difficult. So that is how we solve this one. And I really hope you're copying this down in your notebook. You can go ahead and pause the video here if you need to, so you can see all the different ways we are solving these problems. Now, for our next set of problems, I'm going to show you why it's so important that we know that 7, 6, or why we need to know this simplify strategy over here. So you can try to solve this one on your own, but I think you might see why we need to use that strategy. So I'm going to start with this first problem, 7, 6 times 24. And when I look at this problem, I could try to do a tape diagram, but I'm going to run into a problem because I could label this thing as 24. I could do that. But then I come into the problem, so then I could divide it into 6. So I do all of this and divide it into 6. But then when I go to label what I need, I have 6. But then I also need 7. And I don't have enough in my tape diagram to show this. And I could add more tape diagrams and do more work. But at this point, we know so many other strategies that we should just try to do this numerically instead. So let's try that. So for this problem, I can write this as a multiplication problem all together. So I'm going to do that. So I have 7 times 24 over 6. And what I now have is, remember I did 7 times 24 for my numerator, and then 6 times 1, that invisible 1 that's always there for my denominator. Now when I look at this problem, I could solve this as the multiplication problem like we usually do. But do you know how to do 7 times 24 off the top of your head? Because unfortunately, Miss Coast does not either. So I would have to do a standard algorithm for this. So I have to do 24 times 6. 6 times 4 is 24. Oops, I meant to do a 7. So I could do 4 times 7, which is 28. 2 times 7 is 14. 14 plus 2 is 16. So that gives me 168 over 6. And with this problem, yes, I could eventually create a mixed number out of that, but if you're getting the point by now, this is a lot of work to do because these numbers are not very easy to work with. You would have to do a lot of extra stuff like standard algorithms off to the side. It's very difficult to do the tape diagrams for it. And I'll show you what this would look like if you were to do the repeated addition. For the repeated addition, this would be, I'm not expecting you to write this down, but what this would look like, so I have 7 groups of 24. I would have 24 plus 24 plus 24 plus 24 plus 24. 1, 2, 3, 4, 5, 6, and 7 all over 6. And does that look like any fun to do? I definitely don't want to do that, and I don't think you want to do that either. So what we're going to do instead is we're going to try and simplify this problem. This is so long I have to erase it outside of space. So what I'm going to do instead, I'm going to rewrite this for myself. So I have 7 times 24 over 6, and I'm going to think about what factors can I use to simplify this problem to make it a little bit easier for myself. So instead of having 7, I can't do anything with 7 and 6. There's no factors other than 1 there. But 24 and 6, if I were to think about that GCF, or that greatest common factor, between 24 and 6, I could probably divide both of these by 6. And usually this bottom number will really help you out with what you can divide that bigger number by. So look at this number, look at the bigger number in that multiplication problem on the top, and with a lot of these questions, you're going to be able to divide this number in the numerator by whatever your denominator is. It's not always going to happen, but for a lot of these problems, you will be able to. So we're going to do 24 and 6 divided by 4. So 24 divided by 6 is 4. And then 6 divided by 6 is 1. So that is my new problem. And now I have 7 times 4, which is 28 over 1, or just 28. And that would be the easiest way to get my answer because I was able to do all this math off the top of my head instead of having to do any sort of standard algorithms for my division problem. I'm going to show you one more that is similar to this, and then after that we'll be doing a measurement problem. So now the problem that I have is 7 6 times 27. And again, this is the kind of problem where you're not going to want to do a tape diagram for it because your numerator is larger than your denominator. You're not going to want to just set up a multiplication problem and do the work from there without simplifying. You're definitely not going to want to do a repeated addition problem for this. So the easiest way to do this is to simplify it and then solve. So right now I have 7 6 times 27. And what I can do is I will just write this as a problem like this. And I'll put this right here. Actually, this is supposed to be, oh yeah, it's supposed to be a 6 in this problem. So what I'm going to do with this problem is I'm going to skip all those other strategies that I've learned so far, and I'm just going to think about what can 27 and 6 both be divided by. So I know that 6 can be divided by 2, 3, or 6, and I know that 27 cannot be divided by 2. It cannot be divided by 6. So 3 is the only number that's going to work for me in this problem. So I'm going to be dividing both of these by 3. So 27 divided by 3 is 9. So I'll put that right next to that. And 6 divided by 3 is 2. And even though I am going to have to do some division at the near the end of this problem, it's still going to be a lot easier for me. So now, instead of 7 times 27, I have 7 times 9. And 7 times 9 is one of our facts that we should know. So 7 times 9 is 63 over 2. And now for this problem right here, if you can divide this off the top of your heads, you can do that. Or if you need to, you can set up a standard algorithm, and that's totally fine as well. So we have 63 divided by 2. But either way, even though we still have to do this standard algorithm right here, if you need to, it's still a lot easier than what we would have had to have dealt with doing 7 times 27. So I know that 2 goes into 6 3 times. 2 times 3 is 6. 6 minus 6 is 0. Then I bring down the 3. 2 goes into 3 one time. 2 times 1 is 2. Go ahead and subtract. And then I get my final answer of 31 and a half. So I get a mixed number for my final answer. And again, that would have been really difficult to show if we had to do so much extra work. And if you have any questions about any of these strategies that we've been talking about, please make sure you raise your hands. And please make sure you're copying this down in your notebook today so that you have something to like reference back to when you get to your problem set and homework set. All right, so we're on to our very last problem for today. And this problem is all about measurement. So by this point in the lesson, I should have given you a reference sheet. And on this reference sheet is a bunch of conversions. And conversions help us figure out like how many cups are there in a quart and how many hours are there in minutes. So you are going to really need that chart for today's problem set and tonight's homework. So make sure you take that home with you tonight. You might want to put it in your Succeed book or put it in your homework folder once you're done with your problem sets. So for this one right here, I have 2/3 hour equals how many minutes? And remember, I hope if you do remember, from a while ago back in second quarter, we talked about how I can't just change from hours to minutes and just put a number here. I have to do a little bit of math at least so that I can convert hours into minutes to then figure out my answer. So what I'm going to be doing with this is I'm going to think in an hour, how many minutes are there? So since that is the unit I'm trying to find my answer for, that is what I want to figure out. So in an hour, how many minutes are there? Well, I know that in 1 hour, there are 60 minutes. And this is 2/3 of that hour, and of being that key words, because what I'm going to be doing is 2/3 of, or 2/3 times 60. And again, this is where that like simplifying strategy is really going to help out. So what I am going to do is I'm going to show you the different ways to do this problem, and then just make sure you're following along with me and writing these in your notebook. So first what I could do is I can write this as a division problem altogether. So I have 2 times, or sorry, it's a multiplication problem. So I have 2 times 60 all over 3. And then we have some options past this. So first what I could do is I could do 2 times 60, which gives me 120 over 3. And then I can think of this 12 divided by 3, which gives me 4, and then add on that 0. So that gives me 40 minutes. So I know my answer is going to be 40 minutes. And this is one way I could do that. But if you kind of get nervous or have difficulty with dividing like larger numbers, like 120 divided by 3, we also have some other options. Or if you had difficulty multiplying 2 times 60, another way you could have done this is that repeated addition strategy. So if I have 2 groups of 60, that means I have 2 sets of that number 60. So I have 60 plus 60 over 3. 60 plus 60 is 120, still over 3. And then 120 divided by 3 is 40. And again, I get that 40 minutes. Now, the last strategy, and the one that might be the quickest for you, is you can think of this as 2 times 60 over 3. And you can think about what can I possibly simplify this problem by. So 2 and 3, I can't do anything with that. But 60 and 3, there's definitely something I can do with that. And I don't need to guess and check all these different numbers because this 3 kind of gives me my answer already. Because the only factors of 3 are 3 and 1. So I can do 60 divided by 3. So I'm going to simplify it with that. So now I'm going to have 2 times 60 divided by 3 will give me 20. And 3 divided by 3 will give me 1. So now I have 2 times 20, which gives me 40 over 1, or just 40 minutes. And that is how you would solve that problem. Again, this might be difficult if you have difficulties trying to think about like what 60 divided by 3 might equal. But if you ever need to during these lessons to do like a standard algorithm off to the side, that is fine to do it. We're just trying to move away from that and just solve it like this. So make sure you're practicing those facts, going on extra math every night so we can get really good with that. All right, make sure you have this down in your notebook so you can reference it later. And then later on when you're doing problems, remember that you are trying to figure out, so let's pretend we went from feet to inches. I would have to multiply this 2/3 times 12 maybe instead. So you're always trying to multiply by the conversion rate for that over there. So just use that reference sheet that I gave you. So I'm going to erase this and I'm going to put your problem set and homework set up on the board. So for your problem set today, you are going to be doing number 3. So you're skipping numbers 1 and 2, and you're skipping ahead to problems 3, A through B. And then you're going to be doing problems number 4, A through D. And then you're going to be doing problems 5, A through Z. So I'm trying to get you a lot of practice with this because this is going to be a very useful concept, and that's why this video is so long. So if you don't have enough time to finish the problem set in class, I would really like you to please make sure you're getting that homework done tonight. And if you want to, you can also try to finish this tonight as well because this is going to be really helpful to you. And there are no word problems today, so we have that to look forward to. For homework tonight, you're going to have number 2. Again, you're skipping number 1. Number 2, A through D. And then number 3, A through D. So you have these problems tonight. Please make sure you get them done so that you are ready for tomorrow. Remember, if you need any help, you can either come to the back table for a small group or you can raise your hand and we can come around and help you out. Good job today, and way to keep it up with this really long video. Thanks.